Good afternoon, everyone. My name is Nader Pastar, and I am the country manager at Omnix. Today, I have the privilege of moderating a very exciting webinar. During this webinar, we will be talking about a topic that is on the majority of all CXOs in the region's minds. It's something that I believe everyone's focusing on. Digital transformation is no longer a priority, but a necessity for most organizations. And I think you'd all agree with me when I say that it's now the blueprint of every organization's success. So today I'd like to dig a little bit deeper and talk about app modernization for development teams using OpenShift and how it is essential for every organization and how they are benefiting. With me today, I have an esteemed panel of guests. Ahmed Madkour, Omnix's cloud solution architect. He is Omnix's subject matter expert in this domain and our go-to guy. Very excited to hear from him today. Usama Oransa, the senior solution architect at Red Hat. He is the Red Hat guru and knows the ins and outs of OpenShift. Jitendra, from Ingram Micro, who is the pre-sales solution consultant for Red Hat. Let me kick things off by doing a brief introduction on Omnix and then go in straight to the panel discussion and deep dive into that. So Omnix International is a leading system integrator. We were established in 1987. We have over 1,800 employees, headquartered in UAE and offices across the GCC. Omnix International has two divisions. One is our distribution arm, which is Omnix Engineering, that focuses on everything that is engineering and around the AutoCAD practice. And the distribution arm manages the end-to-end lifecycle of the engineering and AutoCAD domain. Then we have our Omnix Digital division. Our Omnix Digital division consists of 5 main pillars, covering the end-to-end lifecycle of IT. Within these 5 pillars, we have our Smart ELV, covering our low current and passive and active business, from your physical security, CCTV, structured cabling, to your IP telephony. Our second pillar, our audiovisual. Within our audiovisual practice, it's everything from IPTV, background music, meeting rooms, command and control, and our smart meeting rooms. Within our cybersecurity practice, we cover the end-to-end lifecycle of cybersecurity, from everything from your SIM solutions to your identity access, privilege access management, a firewall, and data protection. We also have our smart infrastructure practice, covering the end-to-end lifecycle of infrastructure, from your servers, storage, hardware, hyper-converged, and data center. And our last pillar, which is our software pillar, it is essentially a combination of automation, data, cloud, and our application layer. As you can see, we tend to cover the end-to-end lifecycle of every IT organization. We have over 500 customers within the region and a vast list of references that we're really excited and proud of. Now, with that in mind, I would like to hand it over to Usama from Red Hat, where he will dig a little deeper and talk to us about the Red Hat portfolio and OpenShift and how that has value within the organization.
Thanks a lot. It's my pleasure to be with you today. Let me share my presentation. Let me know when you can see it.
Yeah, we see it, Usama.
Okay, good. So I will take a quick overview about OpenShift, its component, Kubernetes, how people are thinking these days in the technology in general and application modernization. and how the transformation is happening in the industry these days. So let's start by the topics that we are going to discuss. First, I will begin with a quick high overview about containers and Kubernetes components and concepts. Then I will take you through the cloud native development, and finally about OpenShift, its component, the value that OpenShift brings into the market today. So let's start by our first topic, containers. Yeah, everyone is talking today about containers. Containers is similar to virtualization. They separate and isolate the application from each others, but they reduce the resource consumption. They make the resource consumption much more better efficient, because you remove the layer of the hypervisor, of the guest operating system. Imagine if you have 3 applications as in the picture. Everyone has Windows operating system or Linux operating system. How many resources will be consumed by the operating system, the services? While in the right side, in the container technology, you remove this layer at all. You have just the host operating system, and your application is completely isolated from each other within the same operating system. So this makes your life much more easier and more lightweight. You don't move like VMs. You have just small lightweight component, which is the containers. Definitely, there is other benefits that we will discuss today about the container technology in general, but this is from the infrastructure perspective, how you optimize your resource consumption using the containers. So if we discuss containers, think of container as the runtime or the process that's running from a container image. And think of container image like maybe a zip file, file that is formatted in a standard way, that contain all your application binaries or the libraries that you need to connect to, like database driver, for example, any static file, any configuration. It is packaged in the container image. So container image contain everything your application require to run, and this make the container images as portable, because you can move it from one environment to another, from one machine to another, without losing anything, without saying, oh, this works in my machine, this is not working, so what is missing? No, everything is bundled within the container images, and then the container images is instantiated by the container runtime as containers. Now, because you have this capability to store everything in one package, then you can definitely version these container images. And this is a great benefit in the container technology, because you can deploy specific versions in an easy way. You can roll back to specific versions as well. And this remove the legacy things like rolling script to roll back from one release to another. It is very easy and efficient. And because you have this versioning, you will need definitely container image registry that where you can store all these versions of your applications. Now, in the Kubernetes world and OpenShift, we use the pods as the building blocks. Pods has much more better advantage than the container because every pod can contain one or more containers within the pod. And this gives capability for the OpenShift and Kubernetes to seed some complementary containers within the pod, like security monitoring, tracing, and these capabilities are injected inside the pod. You don't have to care about the common services. You just focus on your application. And this is, again, very, very critical things for innovation and agility. You focus just on your application code and let the other common services to be handled by the platform as well. And you can allocate specific CPU, memory, storage, whatever, to every pod in your application. And this gives the flexibility of horizontal and vertical scaling as well. Now, to horizontally scale your application, all you need to do is to specify the number of replica. You don't need to deploy application server, assign a virtual machine, all these kind of legacy things that we used to do with the virtualization. Just specify the number of replica, and Kubernetes and OpenShift will take care of this, will spread it across the OpenShift cluster for you. Now, because we have this concept of versioning, how we are going to move from one version to another, all you need here to do is just specify the strategy. What is your strategy to move from version 1, for example, to version 2? If there is any critical issue in your application, are you doing database schema changes that require your application to be rebuilt from scratch? In that case, you will use a strategy like recreate. It means destroy all the V1 and then create V2 from scratch. This is aggressive strategy when you have database schema changes, or when you have critical bug in your application. You need to stop all the existing customers. But most commonly, you will have new features, enhancements, and this kind of stuff. In that case, you specify the rolling update strategy. And this means the OpenShift will create a new pod from version 2. And once it is ready to serve the customers, it will take one from version 1. And it will do this rolling until all the deployed versions will be V2. And how you do this? Legacy, you need to do a lot of things. Here, you just specify the strategy and let the platform do everything. Now, one of the also benefits in using the Kubernetes and OpenShift is the configuration management. So people used to have Chef and Bobbits and these kind of Ansible, these kind of tools that will seed the configuration, will change some of the configuration, their environment, their enablement of specific features. While this is out-of-the-box supported features in OpenShift, you use the config maps to have the key value configuration of your application. And in every environment, the platform will see the proper configuration in your application bots. And the same using the secrets. And secrets is much more when there is password, username, this kind of information that you don't need it to be human readable. And it is the same concept, it will be seeded. So you don't need actually to have configuration management tool when you use OpenShift as well. Now we mentioned that you can have many replica of your application. So how we can access them? There is the service concept, which is internal load balancer. So again, you don't need internal load balancer or load balancer to distribute the traffic to your replica. While in the legacy, we have many VM, many application server, and you need some sort of load balancer to distribute the traffic across them. And this is out of the box features as well. And any application need to communicate with your application, it will just access the service internal load balancer. Now, to expose something outside OpenShift, there's a nice feature called the route, where you just define a route for your internal load balancer for your service, and that's it. So if you have a web application or external APIs that you need to expose outside the OpenShift cluster, then you need just to define the route, and that's it. Now, because not all the workloads are similar, in some workloads you need to have a stateful workload, you need to persist some data across the application calls, then you can attach a persistent volume to your bot, and you specify the size, and then mount this inside your application bot. And this, if we imagine like MySQL database, for example, you need to have the data files in the storage. If there is any crash in your container or your pod, then the platform will create a new one. It will be attached to the same storage, so you don't have a data loss at all. And this is very useful for stateful workloads. This is one of the ways to have a stateful workload in the containers. There's other ways like stateful sets and others. Also, one of the good concepts here in OpenShift and Kubernetes is the check probes. So the platform will keep checking your application. So when you start or deploy a new one, it will check if it is started or not. It will keep until it reaches the last attempt. If it is not started, then it will fail the start process of this container. If it is started, it will go to the ready. It will test the readiness of this application. Is this application ready to serve the customer or not? So starting doesn't mean the application is ready to serve the customers. Like if you start a Tomcat server, for example, but we need to know to make sure if your application actually can serve the customer, if your endpoint or website can ready to serve the customer. And once it is ready, it will be added to the service as a ready component in your application. And periodically, it will check if this application or bot is alive. If for any reason it is not alive, it will kill this pod and create a new one. And this is a nice feature of health recovery or self-healing. So you don't need, as in the legacy, to keep monitoring proactively your applications and your application servers. No, you get this to OpenShift. It will keep monitoring your applications, and it will self-heal whenever they are not responding. And this is a very critical concepts in the containers. Now, someone will say, okay, I have OpenShift cluster. How I can split this and make use of this cluster across many projects or many environments? There's a multi-tenancy support here. You can isolate the cluster or split the cluster across many projects, many environments, and every environment you can allocate some people to work with some privileges through list access. You can assign a quotation for them. So you have the freedom to make use of the same cluster across many environments, many projects, many initiatives, maybe allocate projects for POC, for research, for this kind of stuff. And this makes the utilization of the OpenShift cluster is much more efficient with this way. So this is just an introduction about containers and Kubernetes and the common terminology that we use in this. And as we saw together, there's a nice concept and a lot of out-of-the-box features that come of this technology that makes your life easy, like self-healing and internal load balancer groups that keep checking proactively in your environment. Now, when we discuss cloud-native development, cloud-native development is a huge terminology that is used heavily in the industry. And the emerging of the different technology that helped this term to be much more mature, like cloud computing technology, where the resources, to get the resources is much more easier these days than what we used to have like 15 years ago, for example. And also the microservice architecture, where you can, instead of building a single monolithic application that contain everything, you can split your architecture and you can split your application into many smaller components, which is the microservices. Now, microservice doesn't mean it can be small, as the name suggests, but it can be large because it is organized around the business capabilities. So you can have like microservice for payment, for catalog, for customer data, for user profiles. So it is a business capabilities, and typically it should have like a business owner that keep asking for features or changes as well. And to say this is a microservice architecture or this is a microservice, then it must fulfill three things. It should be self-contained, that everything it needs, it is contained within this microservices, means the data store within it. It doesn't have any dependency for deployment. So you don't say, if I deploy this microservice, I need to deploy this microservice. No, this is complete dependency that we don't need in the microservice architecture. The same for upgrade. When I upgrade a microservice, I don't need to upgrade any microservice other than the existing one. So this is how you completely isolate these components or microservices from each others, organize them around the business capabilities. Every microservice has its own data management or data store. So this is a decentralization concept. And people commonly refer to microservice architecture as smart endpoint and dump pipes, which means every microservice is smart. It knows where exactly the data will come from and where it will send the data. And the pipe, which is the communication, like service mesh or messaging queues or whatever, are dumb. They don't know anything. They get the message, they send the message, they are not aware of anything. While in the traditional SOA architecture, we have the opposite. We have dump endpoints. The application is plugged within the service bus, while the service bus is smart. It know where, if we am getting some information, it know where exactly it will come get some information from this service and another from this. It will combine them, do some transformation, and return the outcome to the caller. So it is smart pipes in the SOA architecture. This is a commonly used term anyway. And definitely in your microservice, you need a lot of complementary things, as we can see in the picture. You need discovery, invocation, elasticity, registry, pipeline, authentication, all these kind of stuff, as we have mentioned in the previous section, will be seeded commonly by the platform. So you don't need to care about all these common services. Just focus on your application code, in your innovation, in your agile features, and keep the others to the platform. And this is critical when you select any platform, to have all the fulfillment features or the common services implemented for you. Definitely you need automation as well. You need decentralized governance, because you don't need any center point of bottlenecks or center point of failure. And finally, you design your microservice for failure. So this is a critical concept in the microservices. You always assume what if scenario. What if this microservice is failed? What will happen? What are the scenarios that will happen or cascade after this? Like, do I need circuit breaker? Do I need to accumulate some things here? You design this, and then you handle this in advance. You don't keep it as a surprise in the production as well. And if we see how the microservice is evolved, as we have mentioned, you need a lot of complementary service, like service discovery. You need configuration management, routing, circuit breaker, and tracing. These kind of common use services within your microservices used to include some libraries, some common libraries for this. Now with the service mesh, you don't actually need to do anything. You let the platform seed these sidecars or side containers inside your bot, and it will handle all these configurations. And you need just to write the rules that you need, like how the circuit breaker will work, how the routing will work. Do I need to split the routing like 50% to this service version 1 and 50% to version 2? All these kind of stuff, you just write the rules and the service mesh will apply it. And this is critical for the evolution of the microservice technology as well. Now, when we talk about modernization, there is a common patterns for modernization. The most common one is just lift and shift. You don't actually write any cloud native application. You just take your workload from the legacy deployment and put it in the modern way. So think of like if you have Java application that's running in JBoss application server, for example, and because JBoss is available as VM, legacy deployment, and container technology in a modern way, then you can take this application, put it in a JBoss, in a container, and that's it. In most of the cases, there will be no changes. In some cases, you need to do some sort of small tuning, like how you access the file system, how to mount external drive for the logs, this kind of stuff. And in most of the cases, with a provider like Red Hat, this will be provided out of the box in the template or in the container image that provides JBoss. So this is the first way, lift and shift your existing application. So what is the benefit if I do lift and shift of my application? It is still monolithic application, it is not cloud native. You gain all these features that we discussed in the first section. You get self-healing, you get the proofs, proactive proofs. So if there is anything within your application, it will be proactively detected and fixed. You will get some feature that we will discuss later, like auto-scaling, for example. Whenever the workload is increasing or decreasing, you will have these auto-scaling capabilities, plus many other benefits that we discussed, like you focus on your code and let the platform do all the complementary services as well. So you didn't get the full utilization of the platform capabilities, but you get like maybe 50% or 60% by just doing this lift and shift. The other way is connect and extend. When you have a legacy application that is impossible to be lift and shift, modernized, legacy code, like old code that cannot be modernized, in that case, you can complement this legacy application with additional services, additional microservices, and then integrate it within your legacy application, like add a link for chatbots, for example. Then you build the chatbot, you add this link in your application, and that's it. So you modernize, you have the capabilities added by connecting and extending your application. This is another way to enrich the legacy applications with additional layer of microservices or cloud native services. The last one, which is the common these days, is rewrite application. So everyone is rewriting their application to be cloud native. So if you go to any vendor, any large vendor in the market today, you want to purchase a software, like core banking software, for example, they will tell you, okay, we have a container. The latest version of our software is a container version, and this microservice architecture. You will need like OpenShift or whatever platform to execute or deploy this microservice. And this is the most optimum way to make use of cloud native technology, of container technologies, like 100% if we compare it with lift and shift that fulfill 50 or 60% of the value. And all these patterns are supported by OpenShift. You can lift and shift application directly there as it supports many technology and many programming languages. You can connect and extend, and there's a lot of integration bundles available there. And you can rewrite your application build from the OpenShift runtimes, which support many programming options as well. So this is just an overview, quick overview of cloud native technology development, how the microservice is evolved, how the people are modernizing their application and the strategies there, and how the platform actually handle the common services in the cloud native development, where you need just to focus on your application and your innovation or agility and competition in the market. Now, if we talk quickly about OpenShift, okay, OpenShift is a complete end-to-end platform. Kubernetes is open platform, so it provides interfaces for storage, for example, for networking. Anyone can fulfill these interfaces and have the networking or storage or whatever integrated without Kubernetes. So to gain the value of Kubernetes actually as a production-ready platform, you need to complement it with many things, as we can see here. You need service mesh, for example. You need CI/CD tools, DNS service, networking, storage. You need image registry to store your image registry. You need strict security across all the layers. You need authentication, authorization, automation, logging and monitoring capabilities. You need to know what is going on. You need to collect the logs from your microservice applications and search in the logs, identify the issues. So all these kind of stuff is complete solution. You can spend reasonable time integrating these components together. But again, this is not your business focus. You don't need to waste your team on building and integrating all these together. Plus, it is very costly. If you have a security issue on one of the components or a new version of one of the components that you integrated, then you need to check the compatibility. You need to spend another time, and this is happening, by the way, in all these components. So if we see even Kubernetes code over the last few years, like 80% changed. Some features are deprecated, some codes are changing. So compatibility between these components is not granted. It needs someone to handle this for you and keep your application, as we have mentioned, focus in your business capabilities and business applications. Plus even the additional cost of acquiring all these components. So this is what OpenShift actually provides. So OpenShift provides all these capabilities end-to-end for you. And you need just to consume or deploy your application or build your application using OpenShift. So what is the layers in OpenShift? The baseline or the core component of OpenShift is Red Hat Enterprise Linux, or a variant from RHEL, which is the core OS. And this is immutable operating system. So this is very secure. It is immutable. No one can change the core OS except OpenShift. And Kubernetes is the open source version of Kubernetes. There is no proprietary code within Kubernetes that is shipped within OpenShift, and this is let you using the standard way, so you can move easily from OpenShift to any other platform as long as they are above in the Kubernetes standard technology. Now, OpenShift provides this clean area. It provides automated operation for all the layers within the platform. Like you need to increase the cluster size, you just go and add additional machine. I need to automate this, like automatic scaling of my cluster, then you need just to specify the rules for automated scaling in your cluster. If you need to upgrade or batch your cluster, then over the air upgrade, you click a button, select the target version, it will do rolling update in your cluster, similar to upgrading like iPhone or Android phone. So all this is handled by automated operation within the platform. Same for cluster service monitoring, logging, image registry, and this kind of stuff is shipped within OpenShift. You don't need to find a solution for all these components. And by the way, all the component within OpenShift is open source technology. We don't have any proprietary code inside OpenShift. Everything is open. Even if this is a Red Hat technology, we open this as an open source projects. Application service as well, like service mesh, serverless. So serverless is used to be tight coupled with the cloud providers. No, in OpenShift, you can use serverless technology as well. You can use all the middleware component from Red Hat with a lot of runtime support for different programming languages. Same for development experience. We have development tools, CI/CD, automated builds. We have different IDEs that support the application building, either external IDEs or standalone IDEs, or browser-based IDE based on the container as well. Code-ready workspace, which work in the browser and deployed as a container within OpenShift as well. So a lot of things that we can discuss, showing the value of the automated operation and integrated solution within OpenShift. So again, it is standard-based, open source, secure. All the layers are secured by Red Hat and hardened for the enterprise usage. And OpenShift can be deployed in any infrastructure. So think of this like, I have a virtualized environment, I need to deploy OpenShift. Okay, you can deploy it. I have bare metal server, you can go and deploy it. I have private cloud or public cloud, you can use it for OpenShift. And by the way, OpenShift is available in most of the public cloud providers like AWS, Microsoft Azure, Google Cloud, IBM Cloud. It is part of the catalog. You go to the catalog, select OpenShift, and then provision it in the wizard within 1 or 2 minutes. And also, you can deploy OpenShift, and this is very critical. You can deploy OpenShift in Power Machine, IBM Power Machine, in the mainframe as well, Z machines, which is critical in mainframe modernization. Imagine you can utilize these mainframes with OpenShift, and then you can deploy microservice architecture, microservice applications, or cloud native applications within your legacy mainframe deployment. This is a critical feature as well provided by OpenShift. Now, OpenShift is built with DevOps in mind. So you will see things like services. You have a catalog, your application development team will go to the catalog, select whatever the service they want, and then they will provision this. So think of OpenShift as platform as a service. You will go similar to any cloud provider, select the service that you want and provision it. And it supports multi-language like Java, .NET, PHP, Python, Go. All these programming languages are supported in OpenShift with the certified images ready for you to use. And automation, as we have mentioned, in the cluster level, like automating the cluster deployment or expansion or upgrade, or application level automation, like auto-scaling your application, scale up or down, health proofs, all these are provided out of the box. Collaboration, again, this is a great concept in the DevOps, where both the development and operation team are collaborating within the same platform, within specific rule-based access for every member in the team. And they can see from end to end what is going in within the platform. So I'm an administrator from the operation team. I know exactly what is the storage and what are the actual storage behind the scene, but the development team can see like a nickname like fast storage, shared storage, slow storage, and they attach whatever storage type they need within their application. So everyone see things from their perspective, but they collaborate from end to end. And again, it supports multi-tenant, which means you can split the OpenShift cluster across many environments, many teams, or many initiatives or projects within your organization. And again, this is a critical strategy that we are seeing today, which is the hybrid cloud. In OpenShift, we promote the open hybrid cloud, where instead of having less control in the cloud provider, but greater scalability, you can have resources as much as you can, but you don't actually control the infrastructure. It is provided from the cloud providers. And compared to the private cloud, where you have less scalability, you are limited by the existing resources, and you have more control over these systems because they are in on-prem. In open hybrid cloud, we mix between them. So you have part of your application deployed in public cloud, part in private cloud. You mix and match. You exchange the deployment. You can move the application easily from here to here, because they are deployed in OpenShift, and OpenShift provide abstraction layer from the underlying technology. So whatever the hardware, whatever the network, whatever the storage, whatever everything underlying OpenShift, it is handled by OpenShift. So your application need to learn OpenShift. They need to understand how OpenShift is working, and that's it. When they deploy the application in AWS or Microsoft Azure or Google Cloud, they have the same experience, unified experience across them. They will deploy the same application. They don't need to change a line of code in these applications. They will deploy it across all these cloud providers or on-prem without having to care or think about any changes that potentially needed, because OpenShift will handle and abstract all this from you. And we name this open hybrid cloud, open because everything in Red Hat is open source, open technology, open standards, and hybrid cloud because this gives you the flexibility. And think of this in some use cases. Some customers are deploying their application in UAE, for example, and they have Microsoft Azure data center. They can go and deploy the application there. But for example, in a country like Egypt, there is no public data center at the moment, so they can deploy this on-prem. So the same experience provided by OpenShift, on-prem or cloud providers will be the same as well. Now, if we talk about OpenShift from the development integrated tools, as we can see, OpenShift supports Linux or Windows containers. Linux is much more mature as a container technology, but Windows is start to grab things up, and we support both. So you can have specific machines within OpenShift for Windows or workload, and .NET technology has two variants: .NET Core, which can run in Linux or Mac or Windows, and classic .NET applications, which needs Windows machines. In that case, you can deploy it in Windows machines. But most of the customers, as we can see in the industry today, they are moving to .NET Core technology. So we don't actually need Windows containers. But anyway, OpenShift supports both flavors. And from the application perspective, we support many languages, as we have mentioned, like Java, .NET Core, or classic .NET. We support also PHP, Go, Python, and this kind of stuff. So you have the freedom to use. You may use Spring Boot applications. You may use Quarks technology from Red Hat, which is much more optimum because it combines Java into native language. So the startup time and the footprint is much more less than any other technology. You can also use many databases across OpenShift. We have certified images from Red Hat 3D for many databases like Mongo, Cassandra, MySQL, PostgreSDB, and this kind of database. Or you can use the operator to deploy this database, like even Microsoft SQL. You can get the operator from Microsoft and deploy it in OpenShift as well. You can build the microservice technology with all the common service that we discussed in mind. So you just focus on your application and get the platform do the complementary services. You can use functions or serverless technology within OpenShift. And this is very nice feature to use because if there is no workload in your application, it will deprovision the resources. So you can utilize them in another application. And when there is a request coming to this component in your application, it will provision this quickly. Within milliseconds, it will be up and running and serving the customers. And this is where we focus on Quarks as a technology, because it starts in milliseconds and serve the customer quickly. So it is very suitable to serverless technology. So the whole life cycle from building, testing, and deployment is handled out of the box. We have self-service provisioning, we have configuration management, automated build, CI/CD integrated, like cloud native Tekton as a technology for CI/CD, or Jenkins, because many people are using Jenkins, or you can integrate with external CI/CD tools like Azure DevOps or these kind of stuff, because we are open platform. We provide plugins for all these platforms to just integrate with OpenShift quickly. Configuration management, as we have mentioned, logging, monitoring the application, collecting the logs, and this kind also of traceability is also supported out of the box. So your end-to-end cycle is supported within OpenShift. Finally, the operators. We just mentioned the operator as a technology. Operators is a nice concept in Kubernetes and OpenShift as well, because it provides automation for all the common operations. So think of, I need to deploy, for example, Kafka cluster. Then traditionally, I need to hire someone, educate him how to deploy the Kafka cluster, how to maintain it, batch it, how to deprovision it if I need to remove it. While the operator will do this for you. So you hire an operator, like Kafka operator, for example. You will see the provider, like, for example, from Red Hat. So you get this from the vendor who developed this application. And then when you need to provision Kafka cluster, you go to the operator. I need Kafka cluster. This is the specs. It will do everything for you. When there is a new batch or upgrade, it will you will go there and just, I need to update it. That's it. If you need to collect any logs or metrics, it will provide this for you. If you need to auto scale it, it can provide this for you. If you need to remove the cluster, it will go and clean everything that is provisioned. And because this is provided from the actual vendors, it will fulfill the high availability requirement. It will fulfill the best practices for deploying these applications. And every vendor now in the market are providing their software using operator. Even vendors like Oracle, for example, they have WebLogic operator to deploy the things in Kubernetes and OpenShift as well. So this is a nice feature that's provided outside the box inside OpenShift. So it is completely integrated within OpenShift as well and provide all these automation for you. Now, if we see as OpenShift, we can see it is a clear leader in the market in the multi-container and multi-cloud container platform. As you can see, Red Hat RPM, and you can see the ranking and grading of every aspect. We are the top in the market today. We are in the top of the market from the customer perspective, from the feature perspective, because this platform is now like 6 years old and it has maturity in the different aspects within the platform. So this is how we are leading this. We are helping thousands of customers to modernize their application, to do the proper digital transformation with the minimum risk, with them focus in the innovation, focus in the agility, and let the others and common things and infrastructure, common services, platform things to Red Hat. These are some of the customers worldwide. And that's conclude our presentation today. Containers and Kubernetes, we discussed the high level and the general concept in them and the advantage of using this technology. Cloud native development as a way to build your application using the microservice architecture, and how the cloud infra help this evolution, and what is the expected from any platform to help you with fulfillment of the common services. So your team is focused on the application and the business applications. And then we discussed OpenShift with the value proposition. What is the advantage? What is the composition of OpenShift? How it is DevOps friendly? What is the benefits for the application team and development team from the building strategy of their applications, and how they can speed the development with these common services. and how the operation team will handle the automated of the operation. They don't need to bother themselves with the day 2 operations. Everything is handled and automated by OpenShift for the teams. They need just to focus on the most important tasks they can fulfill for the success of their organization. Thank you. That concludes my presentation.
Thank you, everyone. Welcome back. Hope you enjoyed that presentation just as much as we did. We have our panel here today that I just want to reintroduce. Ahmed from Omnix, our cloud solution architect, Jitendra, the pre-sales solution consultant from Ingram Micro, and Osama, who gave us a wonderful presentation from the Red Hat team. If you will allow me, I would like to pose a few questions to you, gentlemen, just to get your perspective on app modernization for development and how clients are using this in terms of OpenShift and how it's helping them with their digital transformation journey. Ahmed, if you'll allow me, I'll start with you. What is Omnix doing to facilitate application development? And how is OpenShift fitting in the portfolio?
All right, so we at Omnix have an in-house multidisciplinary development team with a larger focus on low-code and rapid application development to accelerate digitization of processes and digital transformation of organizations. We've been partners with Mendix for close to 12 years now. Mendix is a leader in the 2020 Gartner Low-Code Application Platform and the Multi-Experience Development Platform, with the highest completeness of vision rating, as well as the 2021 Forrester Wave for Low-Code Development Platform for professional developers, with the strongest current offering and the strongest strategy. With Mendix, we've had many success stories along the way, one of which is with a Dubai government entity, where we helped and continue to work with them to digitize their processes into one single platform used on web and mobile, allowing them to significantly reduce paper consumption on their journey to be 100% paperless following the Dubai paperless strategy. Now, where OpenShift fits in our portfolio, the OpenShift container platform is by far the leader in the latest Forrester multi-cloud container development platform, with the strongest current offering, strongest strategy, as well as the largest market presence. Its stories around cloud-native development, application modernization, and hybrid and multi-cloud management align well with Omnix's vision of becoming the premier partner of choice to provide end-to-end digital solutions for our customers. Of course, not to mention the added value of reducing friction between the development and ops teams, as well as enabling our customers to seamlessly move their applications, Mendix or otherwise, to the cloud, especially with operators, which is a method of managing Kubernetes native applications, like Osama mentioned earlier, from deployment, backup, and upgrades, as well as Mendix's native support for operators.
Great. Thank you, Ahmed. Osama, we talked about Kubernetes, we talked about OpenShift. I'm curious to hear from your perspective. How does OpenShift differentiate itself from mainline Kubernetes? And what benefit does Red Hat add to the community?
Okay, that's a good question. So let's start by the beginning. So think of OpenShift not as a container platform. Think of OpenShift as a digital transformation platform where you can modernize your application, where you can go with the digital transformation journey. You can modernize your application, you can integrate them, you can automate them. So all this is a single platform provided by OpenShift within these integrated capabilities. And you can deploy vendor applications like core banking solution at OpenShift. You can integrate them. You can get whatever the technology, open source technology, and deploy it on OpenShift. So think of it as a complete end-to-end digital platform for digital transformation. And the component within OpenShift, as we have mentioned, the end-to-end application requirement like monitoring, logging, registry, this kind of stuff is provided out of the box, integrated within the solution. So all the components that you usually need as a development team or operation team or security team are pre-integrated, tested, certified, and hardened from the security perspective in the solution. And because we have many experience and accumulated knowledge across the last 6 or 7 years working with thousands of the customers, so the platform is built with DevOps in mind, with the best practices. Okay, so everything is handled like many tools that is provided for the development team, for the operation teams, the integration with the cloud providers that isolate you and abstract you from the underlying complex things that you need to study and be aware of. Like the networking in AWS is different from the networking in Microsoft Azure, different from Google Cloud, but we isolate you from all this. We provide you with the seamless experience, unified experience across them. So this promotes the open hybrid cloud, as we have discussed, without having to learn these cloud technologies or waste the resource time in understanding how they work and how they architect their application there. And it promotes the agility and innovation, as we have mentioned, for many reasons, because we provide everything for you, packaged for you, tested for you, and all the common services are provided, like service mesh and these capabilities, CI/CD pipeline, everything is bundled within the solution. You don't need to waste time of the resources in installing something, because we have the operator, we have the certified images ready, we have the security fixes and patches for these images as well, maintained by Red Hat. So everything is handled by Red Hat. This reduces the risk in your implementation or digital transformation journey. Security hardening, helping, and compliance as well, which is required in many industry, like BCI, DSS, and these kind of security requirement and standards to comply with. They are provided out of the box by OpenShift with detailed guidelines how to implement this as well. Portability is an important concept, because you have this abstraction, then you can run your workload on-prem today, you can provide it and run it tomorrow in cloud providers, in a bare metal, in a mainframe, in the power machines, in virtualized environment, in private cloud. So you have the freedom to move your workload whenever you can think of and run it there. And this reduces the total cost of ownership. Everything is built integrated with you, abstracted from the team. Your team just need to focus on innovation, be more competitive in the market today, because this is the most important things in your business and organization. Be more competitive, be more focused in your business application, how to be more agile, more innovative. And as we have seen, Gartner and Forresters are recommending also the customer to go with a ready-made solution, not to waste the valuable resource time in building and integrating the platform layer, which will not add any value to your business. Just focus on your business layer, business applications, and go for it. And we have seen this across thousands of the customers, thousands of success stories with different customers in many regions, and they are working smoothly with OpenShift to fulfill the digital transformation journey. I hope this answered your question.
Yeah, absolutely. I think it was a very, very insightful response, and I think it gives us a clear overview of the value that OpenShift brings to us, and why most clients are making that shift and changing and going ahead and procuring the OpenShift to help them with their containerization and their move towards the cloud and optimizing and having that value as an overall ownership cost. Jitendra, I'm curious to get your perspective on how you see the world is moving from the legacy applications to containerization, and towards a consumption-based economy. that Osama was referring to.
Thanks, Nader. First of all, before I jump onto the question, I would like to convey my thanks to Osama for your wonderful session and precisely explained about the containers and the overview. And thank you, Ahmed, for your valuable inputs as well. So the containers, like how the legacy applications are moving to the containerized. So many organizations have successfully initialized their cloud projects, basically. So, but they are primarily new greenfield application projects carefully chosen as good candidates for running in the cloud service providers. As a result of these successes, IT organizations are attracted to the elasticity, scalability, and speed of deployment of any cloud computing offers. By using these cloud computing technologies, IT organizations can more quickly respond to developer and line of business demands. So as Osama mentioned in the slides, containers are a key technology that makes many of the service offered by the cloud providers possible. The design of containers opens up many possibilities for automation, basically. So containers combined with platform that provides cloud-like automation are an attractive environment for running applications and cloud deployments. So migrating legacy applications or traditional workloads to the containers can remove many of the barriers to modernization to the new world era. So there are a couple of reasons for moving legacy applications to containers. Number one, scaling and the need to respond quickly. So other one is the positioning legacy systems to enable change on demand. So what are the considerations for moving the legacy apps to the containers? Like it requires a persistent storage, container orchestrations, networking, like building containers for applications, and like kind of public or private cloud challenges. So what's our Red Hat approach is a cloud experience everywhere. So streamlining operations with consistent hybrid cloud foundation and developing applications in containers, and also tools for empowering developers like Red Hat Code Ready Studio and Red Hat Code Ready Workspaces is a Kubernetes native developer workspace. So finally, there are many benefits to containerizing the legacy apps and running old and new applications on Red Hat OpenShift. A container-based architecture orchestrated with Kubernetes and OpenShift improves applications reliability and scalability while decreasing developer and operations overhead. So Red Hat OpenShift's full stack automation, like a developer self-service, like CI/CD capabilities as mentioned, so and also provide a foundation for continuous improvement process. So I hope it helps you answer, Nader.
Yes, absolutely. Thanks, Jitendra, very much for that response. Gentlemen, I'm conscious of time, and I'd like to pose a question to all of you and see what you guys think the challenges in application development are today for organizations. Ahmed, do you want to start off?
Yeah, absolutely. So I'll start with one of the biggest paradigm shifts in the application development, and that is the move from monolithic app development to microservices development, where the former was the standard for a long time in building applications, and now microservices present a paradigm shift in how applications are architected, built, and operated, with the adoption of microservices providing the flexibility in choosing the technology to build the different components of the application to fit the business and technical requirements. And with container platforms like OpenShift doing the heavy lifting to manage and operate the applications once they go into production. The second challenge, I would say, is the friction between the dev and the ops teams, with the classic ways of deploying applications into VMs, with all of the overheads, whether in physical infrastructure or initial configuration, meant that environments took weeks, if not months, to be available for the development teams to use. And that the deployment of the applications would regularly break simply because of misconfiguration of virtual machines, runtimes and their different versions, and other aspects that are not automated or replicable across environments. Now, unlike with containers, where your container image contains everything the application needs to run, from the configuration to the runtime to any other prerequisites. Now the operations team can provision a workspace for the development team in a matter of minutes with any corporate policies in place, and the containers would work seamlessly across the developer's workstation, dev, staging, or even production environments. And also across on-premise or cloud environments with no lock-in or any particular configuration that needs to be done. Developers also wouldn't need to worry about manual processes from building, testing, or deploying the applications with the adoption of CI/CD processes that automate those activities, which result in an increased productivity as well as reducing the human error when they're doing manual operation. And finally, the last challenge that the teams face nowadays is the surge in demand for new applications and experiences to be delivered faster in our competitive market, and that application developers are not able to keep up with the business needs and demands, which is where a rapid application development like Mendix comes in place to allow the business users to build their own POCs, MVPs, or even complete applications in some cases without the need to engage either the application development teams to build the applications or even the operations team for deployment with OpenShift adopted in the organization.
Very interesting, Ahmed. Osama, I'd like to hear your perspective on that question.
Yeah, actually, Ahmed provided a very comprehensive answer. So I would like just to highlight maybe the knowledge. Knowledge is very challenging things in the industry today. A lot of customers are just afraid to go within the transformation journey or digital modernization because of the knowledge of the team. They're afraid there's many options in the market today, many technology providers, many cloud providers, and everyone has its own technology, different aspects. And if we think of this from OpenShift perspective, it provides you with a seamless experience. You need just to focus and learn the nice experience in OpenShift. And it can run anywhere. You don't need to waste your time or team resources in knowing how to implement this in AWS and Azure, in on-prem, in VMware, and all these kind of environment that is very complex. And the knowledge is combined with the options, because in the industry we have many options, everything today. So if you have messaging, we have many options. If you have like networking or storage, many options. And we in OpenShift provide opinionated platform integrated with the best options in the market today. So you don't need to search and look in the cloud native foundry what is the best option in there, because we already selected this, pre-integrated this for you. Also the success stories. So customers are afraid to go within this digital transformation because they are not aware of the outcome. So if they are working with you as Omnix or Ingram, they see how you are already succeeded with different customers in the same industry and domain, and you will feel comfortable with doing this digital transformation journey because others undergo this journey and they succeeded at the end. That's it from my side, because Ahmed already covered many other aspects. Yeah.
Fair enough. Thank you, Osama. And Jitendra, I'll like to close it off with hearing your thoughts on how you feel. I'm not sure if the guys left much for you, but I'm sure.
True.
Go ahead.
Yes, as you mentioned, thanks, Nader. So Ahmed covered more points, and even Osama also covered many things during the presentation as well. So I would like to highlight a couple of points with addition to both the leaders experts mentioned about the OpenShift, and it's based on what the clustering, how the clustering is happening between two pods or two nodes. So OpenShift is playing a vital role, how the cluster is maintaining and clustering management with OpenShift, how the master nodes, how the worker nodes have been placed over there, and also the scaling challenges which have been defeating, like how it can spin up as in one of the slides, it's clearly mentioned that if the workload is not required, automatically it shutdowns or else if workload is there, automatically it's spin up in milliseconds. So it's a good scaling challenges. It's the feature and it's been moving forward. And also the utilization, infrastructure utilization. It doesn't give like much resources to utilize in terms of kind of what if suppose on-prem, if you are saying that as a hybrid code, we are getting more workloads has been utilized and more things have been utilized, and they are useless of sitting over there. But if with this, they can scale up easily and scale down easily by using the infrastructure utilization challenges. So I hope it's clear for you. So
yeah, absolutely. Thank you, Jitendra. Gentlemen, thank you very much for your time. I think it was a very insightful session. Osama, again, I appreciate the presentation. Thank you very much for walking us through the benefits of why OpenShift is creating so much value for so many enterprise clients across the region. I think it goes without saying that as an organization and a consortium, we believe that the combination of Ingram, Red Hat, and Omnix is the right fit for enterprise clients to help them with their app modernization and with their development across their digital transformation journey. So I thank you very much for your time. I appreciate you taking time off your busy schedules to join us for this insightful webinar, and look forward to working closely with you guys and helping you with your future requirements. Thank you very much, gentlemen.
Thank you.
So this is OpenShift. We have two perspectives in OpenShift. We have the administrator perspective and developer perspective. And this is what we have mentioned as DevOps with mind. Everyone has its own access. And because this is the high level dashboard, that's the status of the cluster. If you need to have like alerts for different events, if you need to update the cluster, it's just over the air update. You select the target version and that's it. It will do the rolling update as well. You can see the resource consumption in different perspectives. This is not a monitoring, this is just the high dashboard. We mentioned that OpenShift is multi-tenant, so you can create a project simply by specify the name, development project. This is my dev project, and that's it. So you created the project now that can host your workload within. As you can see, the workload is empty. I didn't deploy anything in this tenant. Now, from the administration perspective, you can assign a resource location. So think of this like a POC project, and you need to limit the CPU, the memory consumption for this project, or even number of bots that can be deployed. You can do this easily by do the hard resource limitation in OpenShift. So this is from the administration perspective. You provide the project, the tenant, and then the development team can go and then assign the different resources for this project. You can have like project manager with a view only rule. You can have a development team with edit rule. You can have team leader or architect with edit rule as well. Or you can tailor these rule access based on your access directory. Maybe you have someone just to deploy the application, someone just to read the logs. So you can tailor this more and more as per your requirement. And this is the tenant. So how I can add the workload now or deploy my application? There's many options in OpenShift. You can go just from the Git repository and give the repository URL to OpenShift, and it will auto-detect the technology. As you can see, it auto-detect that this is Java application and it needs a Java image to build the application and then create the container. Or there's other options like you can have container image built outside OpenShift and then you can deploy it inside OpenShift. Maybe you need to provide a Docker file or YAML file for a template, or maybe from the catalog. And this is the most interesting part, which is the service catalog. In the service catalog, you can check the technology that you would like to have, like what is the programming language, Java or .NET or Ruby, Python, whatever, and you can deploy your application. So if we deployed one application together, like .NET Core application, for example, I need to create an application. So what is actually required, again, is the source code. You need to specify the source code and what is it is the main branch, the main branch in the source code. And that's it. Provide the application name if you'd like. What is the configuration for your application? Like how many nodes, for example, you can define the scaling, for example. Do you need to have a route for your application to be exposed outside the cluster or not? So these kind of configuration that you can tailor based on your deployment requirement. And if everything is properly configured, especially the Git repository, and if I click create, then it will be successfully created for you. So what will happen behind the scene? OpenShift has what's called source to image. You provide the source code, OpenShift will get the source code, it will build the application from the source code, and then the application binary will be placed in the container image that's required to run this application, like .NET Core application or Java image, or according to the required technology. And then this container image will be stored inside the internal registry OpenShift, and then the pod will be instantiated from this container image. So everything is automated for you. You need just to focus on your code, provide the source code or Git repository to OpenShift, and everything will be handled by OpenShift. So if we see the build here, we can see the build logs. You can see it get the code from the source repository and start building the binaries. These are the DLL files from the .NET Core application. And finally, it pushed this image to the container image inside OpenShift. And then it instantiates the application as a running pod. You can see here, this is the running pod. And we can scale it easily. Let's scale it. This is the manual scaling. You need just to click on the arrow up or down if you need to scale it up or down as per your requirement. And then in the resources, it will follow the scaling command that you specified. Here in the deployment, you see the update strategy is rolling. So if I build a new version of my application, it will do the rolling update as we have mentioned. And if we change the image or the configuration for my application, it will trigger automatic deployment of the application. So everything is automated for you. You need just to focus on your application. And in every pod, you can just go ahead and see the logs of this pod. You may enter into the terminal inside the pod. You can execute whatever command. So think of this if you need to grab something, configure something, or if you need to install a database schema, then you need just to go to the pod and execute this command. And environment is the configuration management that we have mentioned, using either the config maps or secrets. You need just to see them here, and it will be populated within the runtime. So now we have 3 pods, and we have service. This is the internal load balancer, and we have route exposing this outside the cluster. If we click on this, we will see the application exposed outside the cluster and up and running as well. So this is the first way to deploy the application OpenShift. Just to go ahead and provide the source code from the catalog, select the technology, and you can deploy the application. You can also use some sort of CI/CD. We have 2 options, as we have mentioned. Tekton is a cloud-native technology, or we have Jenkins as well. Many customers actually are using Jenkins because they used to do this over the last years, so they have experience in doing this. And Jenkins is very rich with plugins for the different technology. And we ship Jenkins within OpenShift as well with a ready OpenShift plugin for you. So you don't need to bother yourself with configuring or installing the OpenShift plugin. It will work automatically within OpenShift. So now it will grab just the certified Jenkins image, and then it will instantiate the bot for you. Let's wait until the Jenkins is started. Let's see, this is the monitoring capabilities. This is from the development perspective. We can dig in whatever they want from here. This is different from the administrative detailed perspective. This is limited to the project and the running pods inside the project. Okay. By the way, you can use Helm chart as well to deploy your application. You can use the operator-based deployment as well. So if we go back to the topology here, you can see it is still up and running. Let's scale this down as well. It is just a click of a button and you scale your application to the required number of pods. Now Jenkins is up and running. And by the way, when you deploy these common services in OpenShift, you get single sign-on. So if I open Jenkins, it will ask my permission to do the single sign-on with OpenShift. So your role-based access is extended within OpenShift as well to the complementary services like Jenkins and others. In the meanwhile, this is a simple Java application based on a Maven. And it contains CI/CD for Jenkins. It contains also Azure pipeline DevOps file, so you can also use Azure DevOps to build this application. And this is Jenkins. Let's build a pipeline now. Maven pipeline. This is just describe that the application is using Maven as a build script. So now we have this pipeline created. This is the build triggers. So you can trigger this pipeline if there is a commit, new commit in your source repository, maybe periodically in the morning or at the end of the day. So whatever, you can build it externally by specify a URL to start the pipeline. So you have many build trigger options. Here, let's get the pipeline from the source repository. I host it in Git repository, and then let's copy the URL here of my Git repository. It is main branch. And then this is CI/CD Jenkins file. So I am referring to Jenkins file in my CI/CD folder in the Git repository. And it is best practice to store even your pipeline within your Git repository or source repository. So everything is contained within the source repository. So let's open this in GitHub here. So this is the Jenkins files. It defines some parameters for some options, like do you need to run SonarQube, do you need to scan your code, what is the project in OpenShift, and then this is the actual pipeline. It will check out the code, it will do some sort of testing and verify and publish the results of the test kit. It will do some sort of code scanning and unit test coverage. It will package the application. It will then deploy the application. And then finally, it will do some sort of smoke testing to make sure the application is running actually. So it is a simple pipeline. So with the first execution, because it will not detect the parameters, it will fail. With the second execution, you can then build with the pipeline. So I didn't deploy any SonarQube, so let's say no, and then deploy my application. So now it will do what we have mentioned in the pipeline. It will do source code checkout, and then it will run unit testing and make sure the code coverage is fulfilled. And then it will build the application package. It will ask me for permission to deploy the application. And this permission can be repeated. So you can deploy to application development environment. And then when you test everything is working fine, you can gain a permission, another permission to deploy to the staging environment, for example. So you can use the pipeline to promote the workload between different environments. So now in the unit testing. And by the way, OpenShift is shipped with command line tools. So you can deploy. You can just download the command line tools from OpenShift. We have OpenShift command line. We have Helm chart. We have Odoo for the development team. We have rich of tools. We have serverless also command line tools, and it works in the same way. So if we execute OC git pods, OC project, and specify the project as dev project, for example, and OC git pods, it will return the existing pods within this project. And you can use kubectl as well to get the pods. Both are working fine, and you can see it is even the same format for you. So let's go back to the pipeline. Now it is asking for permission for the deployment. I will grant the deployment permission. Now it will check if this application already deployed or not, and it will decide if this is initial deployment to OpenShift or it is incremental deployment because the application previously deployed, so it is just adding a new version or something. So now if we go here, we will see the application is coming, and we have two main modes for deploying in OpenShift. One is from the source code. As we have seen here, we provide the source code and it builds the application from the source code. The other way is to build outside OpenShift the binaries and deploy the binaries to OpenShift. And this is the other way that's commonly used in OpenShift. When you have the CI/CD pipeline implemented within OpenShift or outside OpenShift, the build here will take just the binaries and package the application. So now the application is actually built, and you can access the route as well from here. You can scale the application and you can do whatever you want. And because this is a pipeline based, you can modify the pipeline and you can add many options to automated testing and other stuff. Before we conclude, let's show you the operator as well. This is the operator hub integrated with an OpenShift. So for example, if I need to deploy like Kafka cluster, for example, you see this is provided from the different vendors. I will select Kafka. This is the capability of this operator. It will do the installation, the upgrade, the lifecycle management, and insights. It will not do autopilot. Autopilot means auto scaling. So to install it, I need just to specify which project do I need to install this operator. I say in the dev project, and that's it. So once the operator deployed successfully, I can now automate the provisioning of the cluster, the upgrade, everything from the Kafka perspective. I don't need to have a solid knowledge or follow the documentation or the best practice because it will be fulfilled by the operator. So until it is being installed, let's see the monitoring capabilities for the administrators. They can see much more information and compared to the development team. They can dig in whatever component in the clusters and whatever nodes they want, and they can see the utilization and other stuff as well. This is much more detailed information, and they can open even Grafana UI because this is based on Grafana. Prometheus is collecting the logs and the matrices from the different pods, and Grafana is visualizing them as well. So if we go back to the installed operators, we can see the operator is now installed. So let's assume I need to provision a Kafka cluster. I will come here and say I need to create a Kafka cluster, give it a name, for example, my Kafka, for example. And then you can configure whatever components of what is the configuration, how many Kafka broker I need for example, Zookeeper, for example, certificates, everything you can just specify here in this wizard, or you can also see it as a YAML file as well. But let's do this from the form based, and then install it. What will happen now behind the scene? This operator, as if you hired an employee with Kafka knowledge, it will install this Kafka cluster within OpenShift. It will create all the necessary components like config maps, secrets, stateful sets, services. Everything will be handled, and the routes and everything needed for Kafka to work, it will be created. And once you finish with this Kafka cluster, you can come here and delete it. You can upgrade it if required. If we open this Kafka cluster to see the resources, you can see there's many secrets, stateful sets, pods, services. All this kind of stuff is in the creation mode. And once it is created, within a couple of minutes, you can go to the services. This is what we have mentioned as the internal load balancer, and then connect to the Kafka using the IP address and the port, either with the TLS or not, or you can use even the name as a DNS entry, so you can connect with the DNS name and the port, and you can just start consuming the Kafka cluster. It follow the best practices, the high availability, everything is fulfilled by the vendor of this operator. You don't need to waste your time on this. You just consume this, and this is very, very critical things for digital transformation for the teams who are afraid on how to proceed with digital transformation journey, application modernization, because everything is handled for you. And if you see the operator hub, it has many sections like AI, machine learning, big data, database, developers tool, security tools. There's many security tools, OpenShift optional component that you can install. And this kind of stuff that's clustered for you, and there is a marketplace to purchase if it needs a license. Some from the community you can just consume direct, some from Red Hat, and many options, and many companies. Almost every company in the world now is using the operator to provision their applications based on the best practices and high availability options as well. I think this concludes the presentation for today. We just see how efficient OpenShift in provision the application using the source to image, provide the Git repository only, or building a pipeline within OpenShift. We didn't take more than a couple of minutes to build the pipeline and deploy the things in OpenShift. Everything is hosted in my source repository. I can use this Jenkins, I can use Azure DevOps as well. Same concept, same parameters, same steps as well. I can use Tekton within OpenShift as a container native technology. I can use the operator to build and deploy my application as well. So many options, many integrated solution like monitoring, logging, storage, networking, everything is handled for you. Cluster upgrade, scaling, auto-scaling, even application auto-scaling. I can go to the workload here and define horizontal bot auto-scaling. I need just to specify what is the CPU utilization, what is the minimum and maximum replica, and what is the metrics. If CPU utilization exceed 80%, for example, scale the application as well. So this is how you have cloud experience within on-prem and across all the infrastructure, like cloud provider, on-prem, bare metal virtualized environment, without having to care about or understanding the infrastructure. OpenShift will handle this abstraction for you and provide end-to-end solution for you. Thanks a lot. I hope this demo, a quick demo, helps.